Hello, everyone, and a very warm welcome to today's exclusive Fireside Chat session on Edge versus Core, Rethinking Data Center Architecture for AI and Real-Time Applications. I'm your host, Khushi, and I'm delighted to have you with us today. As AI workloads grow more demanding and real-time data becomes central to user experience, organizations around the world are reimagining how their data infrastructure is built and deployed. Traditional core-heavy data center models are being re-evaluated, giving rise to hybrid edge-enabled architectures that promise lower latency, greater scalability, and improved responsiveness. So, in this conversation, we will dive into what's driving this shift from global CIO insights to the infrastructure challenges emerging across industries. We will explore how enterprises are adapting to support latency sensitive AI workloads, what role Edge plays in real time application delivery, and how to navigate security, compliance, and architectural complexity in this increasingly decentralized world. Our expert speaker will also share insights into common missteps, developer readiness, and bold predictions for where data center architecture is headed in the next 5 years. So let's get started and unpack how Edge and Core will define the future of compute. So without further delay, I would like to welcome our distinguished speaker for today's session. To facilitate the session, folks, please join me in welcoming Mr. Naresh Singh, who is currently serving as the Senior Director Analyst at Gartner Research and Advisory, where he is part of the Technology and Service Provider Research Group. He focuses on delivering research and advice to product managers in technology and service provider organizations around the world. He has more than 20 years of engagements with clients globally on technology topics such as AI infrastructure, zero trust, AI security, GPU AAS, and Cloud IaaS. Mr. Singh also regularly advises governments and enterprise users in their AI, security, cloud, and network infrastructure initiatives. It's such a pleasure having you, Naresh, here with me today.
Thank you very much, Khushi. Good afternoon to all of you. It's my pleasure to talk to you.
So now, without further ado, let's get started. So to begin with, Naresh, firstly, I would like to ask that based on the conversations with global CIOs and infrastructure heads, what do you think is driving the rethinking of traditional core-heavy data center models today?
Yeah, Khushi, to understand this, we have to really go back and see what is happening to today's business, right? Businesses are increasingly distributed today. I mean, their workforce works from anywhere, and they are used to kind of computing and getting access to things anytime, anywhere, right? Even their offices are becoming more distributed as companies grow globally. They are having operations everywhere, both nationally as well as globally, right? Plus, we have increasingly, a lot of sites which are in very, very remote locations as we scale our business, expand it further to meet different needs of customers, in all different locations, both nationally and internationally. Okay? On the other hand, also, businesses and individuals are increasingly becoming more and more reliant on technology, right? So our dependency on technology has increased significantly. The very fact that if we lose access to the internet or even the applications that we use daily, our capability to operate and the continuity of the business is seriously challenged, right? So without technology, we are kind of non-operational these days, right? So this means that we have to look at enabling technologies everywhere, not just in one location, but in all locations, and be able to operate even when you have not access to a centrally located, resource of the technology which you have in hosting, in a central location. So this is one of the reasons why edge computing has become a key theme increasingly among businesses today.
Yeah, and that really highlights that how the shift is being driven by both demand for agility and the growing limitations of legacy models, I believe.
Yes, Kushi.
Yes. So moving forward, Naresh, how do you think that enterprises think about the balance between edge and core in a hybrid world?
Yeah, so absolutely, I think they need to plan out very, very effectively when it comes to decisions around, whether to, go for a centralized model like cloud or a data center operated business, or think of, applying technology there at the edge. So to do that, they have to look at, their needs, their applications that they are using, and see whether the applications they need make sense to be hosted centrally, or they should be better distributed in a distributed architecture. And the key factors that one has to evaluate here are absolutely the latency needs, right? So certain applications are um, very latency sensitive. That means they cannot operate if the latency is high. The latency means basically the response time that the application has. When you kind of communicate to an application, the application responds back to you, right? So if the response time is too long, some applications do not work that way. Okay, and also the users don't want to generally wait for response. So users are very impatient these days, right? So latency is a very big deal, and to serve users who are used to instant gratification in today's world, uh, uh, that the businesses have to make sure that they are able to kind of address the latency needs of the users as well as applications. That's factor number one. The second factor is that the data, right? As you know, the data is the new world's gold, right? So everybody is like talking about using the data effectively, the data that you have, right? So AI is one of the these the data kind of data rich, data ready kind of business application that we are talking about today, right? So it's a fact that a lot of data actually get generated at the edge, right? Because data get generated when people do things, when people consume applications, when people talk to talk to the to the machine. They generate data, and this data is becoming more and more important to businesses, right? Customer data, employee data, all these things are very important, and the operational data too. So when we are looking at using the data, right? The very important thing is that the data and the application needs to be near, right? So particularly when you need a lot of data, uh, the access to the data becomes very critical, right? So if there is a delay in getting access to data, the processing of the application does not work well, right? So therefore we have this term called data gravity. Data gravity. Data gravity means basically the data has a very good kind of nature that it grabs the applications near to it, so that it's like a gravity, it draws the applications. So the applications are better served when they go near the data and not like data going to the application. It's difficult to take data to the application. It's much easier to bring application to data, because data is like heavily distributed. They are everywhere. They're in all the edge. To basically kind of consolidate the data from all the locations to a central location becomes a huge enterprise, very costly and very time taking, and very operationally complex initiative. So rather than doing that, it's better to kind of look at which applications are data intensive. So let's take those applications and spread them where the data is, so that they can use the data effectively in the location where the data is generated or where the data is lying, right? The third factor that we have to evaluate is the security, right? So increasingly, as you know today, the businesses are operating in different remote sites, right? And they are using very much strategic kind of technologies in different locations, right? And some of these technologies are very sensitive, and having intellectual property sensitive data, right? So you want to secure all these things. So in fact, if you look at a scenario where today businesses are like kind of competing among each other, countries are in geopolitical tensions, right? So in this kind of scenario, there is a lot of cyber risk involved, right? In fact, in the recent war with India, a lot of businesses actually were attacked by their adversaries, right? So therefore, sensitive sectors like defense, like oil and gas, utility, they're in high risk, and they're the guys who also have a lot of distributed sites. So absolutely, you have to secure all these sensitive infrastructure, sensitive data lying everywhere, right? But how do you secure this? It's another huge challenge, because security in the past was all about having a very very fortified castle, or what you call a data center, or a centralized data center, which was like fortified. You had a big moat around there. You had a huge walls, or what we call as firewalls. You might have heard word called firewalls. So once you secure that one location, everything is secure, right? You have a good sleep. But now, what happens when you have to secure everywhere, including places which are very remote, where you don't have experts to secure it, right? So security becomes a huge challenge as well. So you have to be very, very careful. Can I secure the edge, right? And if I can secure the edge, how do I secure it, right? How do I secure it? And the other aspect is also that you're not looking only at external threats. There's a lot of internal threats also. Internal threats meaning you have guest workers, you have visitors in all these different sites, right? So, and sometimes they also need to be given access to the network or access to some of the resources out there. How do we evaluate whether they are genuine people? How do we know that they are not getting access to the wrong resources? So therefore, you have to also secure not just the connection of the remote location to the cloud or to the central data, but also you have to secure the resources right there in the remote location also, right? So security becomes a big factor to evaluate when you're looking at whether to take a edge centric approach for a particular application, or going for a core or a cloud based approach for an application.
Yeah, right. And this is also a very thoughtful perspective, because it's clear that finding the right balance is more strategic than ever.
Absolutely, absolutely. Yeah, certain things will just work better on cloud. Why take the pains, right? But on the
Yeah.
other hand, there are those things which really require an edge approach, because centralized approach will just not work, or you just cannot do that because of regulatory, or because of compliance needs as well.
Yes, exactly, Naresh. And moving forward, I would also like to ask that which industries do you think are leading the charge in edge adoption, and what unique infrastructure challenges are you seeing that are emerging there?
Yeah. So the industries that are really needing edge today are those industries that have a high intensity of activities, or edge concentration of their users or their customers. So one of the a few sectors that come to mind are retail, right? So today, I mean, retail is like booming in India, or booming everywhere in the world, right? You have increasing a number of retail businesses, kind of expanding out to different locations, beyond even the tier one cities, right? So in those cases, then we have to make sure that those retail locations have adequate computing and adequate access to technology, right? Also, we are also looking at improving or even transforming the experience of retail. So, meaning that we are talking about use of advanced technologies like computer vision, or smart security, or like a customer engagement using kind of edge and remote technologies, right? So that if you see somebody who is of high net worth or valuable customers coming, you provide enhanced experience to that user. So let's say in a bank branch or in a shopping mall, you see that there is a very high net worth individual. You want to provide him the best services. You want to also provide him enhanced experience, like kind of giving a deal on the mobile devices that he sees, right? Then that helps to kind of make a decision for him right there itself. So these are strategies that today's businesses are increasingly using. So, okay. So, for example, I mean, there are banks who are beginning to provide wireless connections, wireless access uh, free to their users, right? So that they can use the Wi-Fi that's provided by the bank, and using that, they're able to know who is coming to their branch, what is their social, kind of trends, and what are their social, behavior. So in a quick time, they're able to make a kind of analysis and insight on the customers that they have that are live in their branch, right? So this is the kind of nature of today's digital business, that edge is becoming a critical differentiator in their business. Okay, enabling new experience. The other, sector that I'm talking about is manufacturing. So manufacturing generally always have, their factories, their logistic units always typically in remote locations. Why? Because the factories are not allowed in high populated density zones, right? In the cities and all, they don't. They're not allowed there. So typically, they're always, even in the city, they're in a remote zone, right? And they're also sometimes in typically industry hubs, which also can be quite remote, right? So therefore, manufacturing companies definitely have a very, very intense edge requirements. Okay, so they also sometimes have huge plans, huge sites. So therefore, their edge requirements can be very, very intensive. That means they may have enough compute capacity requirement, enough network requirement that will serve multiple buildings, multiple users in that site, right? Use sites. So actually, they are a very good kind of a use case for uh, edge intensive technologies, right? So for example, like the private 5G, private wireless, which are like latest technologies, like in private wireless, like Wi-Fi 7 or private 5G technologies. So these are actually great user use cases where edge is a very, very natural kind of technology for them. Okay. Yeah, and then also manufacturing has got a lot of non-traditional technologies involved. So non-traditional meaning non-IT technologies, legacy technologies that serve their manufacturing robots, their infrastructure that is necessary to the factory, the plant, machinery, etc. Those are completely separate technology. What we call as operational technologies, right? So enabling the operational technology to use the latest IT technologies is also one of the major trends that we are seeing in what we call the Industry 5 or Industry 6. Basically, they're all using internet. They're all going to use things like AI, so that these traditional legacy applications become more intelligent and more effective, right? So there's a convergence going on between traditional and new modern technologies that are coming from the IT side, right? But having said that, these technologies are actually implemented and managed by different teams. The IT team is managing the IT systems, but these not older, I mean these legacy applications which are industry centric are managed by a separate team. Okay, so these teams don't work together, and they sometimes don't trust each other or don't work very regularly with each other. So therefore, there's a lack of kind of understanding about each other, and also about the technologies of the different groups. So this leads to challenges in terms of how do I converge my network, how do I converge my technology so that you can use the best of both worlds, right? So this is one of the infrastructure challenges that we see in edge locations like these. Okay, there are new technologies like cyber physical systems coming out. There are OT security options that are now being offered by many vendors to address this particular challenge. Okay, then other sectors that are also very edge centric includes the utility sector, oil and gas, kind of power, gas, distribution. Again, they are very remote locations, right? So, electricity generation, for example, they have got hydro, electric dams, in the most remotest parts of the world, right? Some of them operate in the highest mountains, in the highest, the most remotest villages in the high ridges of Himalayas, right? And the oil and gas, they have got oil drills in the seas and the oceans of our world, right? So all of them have got very unique requirements when it comes to their technology, right? And some of them are very technology matured also. Like for example, oil and gas, they are very highly dependent on analytics, right? Data analytics. It's all about basically, kind of exploration of the mineral resources, the seas, and the oil, right? And it's like throwing up huge amount of data, petabytes and petabytes of data, and they have to go through those data to understand, the insights out of them and act accordingly. In some cases, they have to also apply immediately, right? So there are challenges, they can preempt the challenge. For example, let's say manufacturing robot or a wind farm, right? Wind farm, those wind farm, those things. Knowing, the stress and the maintenance requirement of that can prevent a disaster to happen. So this is when you apply technologies like AI and machine learning to apply things before they come, and to apply changes or corrections to things before they become a problem, right? So therefore, edge technologies become more and more important requirement to serve this kind of sectors like these, right? So these are some of the industries where I'm seeing a huge need for edge technologies. Kushi.
Yes, and that also gives us a great view of where innovation is happening first and what others can learn from it, actually.
Yeah.
Yes. So moving forward, Naresh, do you think that with AI workloads becoming heavier and more latency sensitive, how are enterprises, re-architecting their data center strategies to support this shift?
Yeah. So, Kushi, AI workloads are very compute intensive. So they need very fast compute. Okay, that's the reason why we use graphic processing units or AI processors, right? Which are kind of used to compute at a much higher throughput, and much faster than a normal compute resources like CPUs or normal servers and on computers, right? So they're very compute intensive. Also, we see an emergence of a lot of new foundational AI models which use transformer technologies like ChatGPTs, GPT-4, GPT 3.5, and ChatGPT is basically the interface towards the user, the chat interface. But behind that, you have some very popular models, AI LLM models, large language models like GPT-4, GPT 3.5, operator model. So these are very large models. That means they have billions of parameters. Billions of parameters means that they have a lot of memory requirement. Okay, so therefore, running these models, which are very popular, requires a lot of significant memory, significant storage memory, and memory which is like locally available to the processor very nearby, so that they don't have to kind of wait for the memory to respond. So they need typically these AI workloads require very fast access to memory. Okay, so therefore this is a huge challenge when it comes to applying it to edge, because edge has always had challenges in terms of that they are very remote. Secondly, they have less power availability, so they are typically runs on, sometimes have to run on battery. And and generally, the kind of equipment that is designed for edge are supposed to be less intensive in terms of compute, less power, very efficient on memory, very efficient on the compute capacity. So they have to be optimized for edge. But now AI workload, on the other hand, is extremely hungry for compute power, right? Hungry for memory, right? And they also need a lot of power to run. The amount of power that is required to run an AI system is easily 5 times more than a normal, compute processor, like a normal AI, normal, server or a normal integrated system. Okay, so this is a big challenge for AI workload running it in a edge location. And AI can also be extremely latency sensitive, particularly if AI has to be very dynamic, or has to serve a machine rather than a human. So machines, for example, like a robot, have to take immediate response, does do immediate things. It can't wait for a cloud to respond before they take a decision. A classic example would be a kind of a self-driving vehicle, right? A self-driving vehicle has to carry a data center in its bonnet, in its trunk. It can't even communicate to a data center somewhere else, because there is somebody crossing the road. It has to decide what to do, right? Which direction to move. So therefore the computing has to happen right inside the car itself. Similar like that, even the factory use case is somewhat like that. So particularly if you're talking about robotic factory, right? So such kind of use cases, like where machine cannot wait for we call it as machine latency rather than human latency. Human latency can still be kind of quite generous in terms of kind of okay with kind of even little bit higher latency. That also depends on the type of uses. Also, humans also cannot really wait for certain kind of use cases as well, right? So AI can also be that way, very very sensitive to latency. So therefore, these are some of the challenges that AI brings when it comes to deploying it at the edge. Hmm? So what are end users doing? What are enterprises doing for this purpose? So they are looking at various kind of techniques to address this challenge. One is they are trying to look at making the AI more optimized for edge adoption. Okay, what do we mean by this? Let's make the AI models lighter. So we use techniques like quantization. Quantization is basically removing away unnecessary elements or unnecessary features and functionalities from the model, so the model become less memory consuming, or takes less amount of computing power. So this is called as quantization of AI models. So there's a lot of work that is going on among the AI industry, including the chip providers and also software tools vendors, who are helping them to reduce a very popular AI model that is very heavy to even run on even a mobile device as well. Okay, so of course there are some challenges with doing that, but every edge AI requirement does not have to be similar to what you do it on the cloud. So the edge requirement is different from a generic requirement that we have in a office or in a home, right? So it doesn't have to need everything that AI does. It needs a certain kind of things which AI can help them. So for that, you don't necessarily need to go in for a very large model. So therefore, there is also an emergence of what we call as domain-specific small language model (SLMs). So basically, there are going to be models which are architect, the AI models that are designed to meet certain needs of a domain, like in an industry. Okay, or even in the industry also, there will be models which will serve certain processes, different processes. So different models for different processes. So these kind of AI models are becoming more popular because they kind of address the industry need and also the edge requirement better. Okay, so that's one way. Uh, Second thing is, how do we make the edge more equipped or more capable of running AI? So uh, so whatever you do, AI is still going to be more intense than a normal edge workload. So therefore, is there a way to make the edge use new technologies like GPUs, right? So there are even the vendors like Nvidia and AMD, Intel. They are trying to make AI technologies that are suitable for edge, right? So they will be much lighter, they will be more compact, and they will use less energy. Okay, so they're also designing edge technologies, edge equipment for the purpose of edge, specific for edge, right? So the businesses have to then look at, okay, can I apply these new technologies and use it at the edge, right? How do I architect it properly, and how do I select these technology and deploy it at the edge? So these are the two kind of approaches that we see that customers are taking when they're looking at edge deployments of AI.
Yeah, absolutely. Because it's evident that AI is not just transforming software, it is the very infrastructure that runs it.
Correct. And also, one is to aware that the requirements, the infrastructure requirements at the edge is very different from the infrastructure requirement in a central data center or in the cloud.
Yes.
So that is also true for AI as well. So in AI, for example, requires a lot of resources, a lot of GPUs. Okay,
Yeah.
a lot of GPUs basically to train the model. But in edge, you cannot have that many resources, right? So you have to do with more optimized, heavily optimized, highly optimized infrastructure for doing edge AI. Okay, and also you cannot do everything of AI in the edge. You have to do certain things that make sense to do in the edge. Right? So this is a very fine balance you have to take, and also what you do in the edge uh, and what you do in the cloud is a factor of how what makes sense where. For example, let's say you develop like earlier I said, the data is lying in the edge, and if I want to use that data in the edge, I have to bring it together somewhere and then apply it to the model, AI model or the application, right? But those data can be very sensitive, and you don't want to expose it to the external world. So you still need to consolidate somewhere in one part of the edge, or a more remote, concentrated location, and do the training there, right? And then once you train that, then you have to decide how do I then use that model. So the model use can be either you put in the cloud so that you can serve more users, which is more easier to do because you just have to take the model and then put it into the cloud and then run it over there, and people can have access to it using internet. The other thing is more harder, which is like if I have to also install it and deploy it at the edge also. And when I say edge, it will be multiple edges, right? Every enterprise will have different locations which are at the edge. So that means I have to basically run and operate an AI which is distributed. It's an extremely challenging, scenario. It's a complex scenario. Okay, that is harder to do and harder to, it's costlier and harder to manage, right? So we have to take the right call that makes sense for the business, right? So at the end of the day, there has to be business outcome, and the business outcome should be manageable, right? And it should not be like coming at a high cost that it doesn't make sense.
Exactly, Naresh. And this is something that is, very also beneficial for the, maybe the future generation, because catching up the hold is something that is very essential nowadays.
Yeah.
All right. So moving forward with the next one, I would like to ask that as data becomes more decentralized, how do you think that organizations are approaching security and compliance at the edge? And is zero trust enough?
Good question, Krushi. So centralized data is always a challenge because you don't want to get those data compromised in any case, right? And since they are decentralized, how do you have visibility of the data? So do you know what data is out there, and in whose hand they are, where are they located, right? So it's always a huge challenge. And also the organizations are having different users and interaction with different parties in the edge as well, right? So there is a traffic of a lot of people uh, in those edge locations, and there may be sensitive data lying in those locations. Therefore, absolutely a zero trust paradigm or a zero trust principle is is the starting point. You don't want to give access to anything without explicitly knowing that somebody has the right to that access that data. So this is called zero trust, right? Explicit trust. And, basically ascertain or make sure that is the explicit trust on the user. Then only you give access to the data that he's trying to use, and also give data that is what is required, not more, not less, right? So this is the principle of zero trust. Okay. However, no matter how good your zero trust solutions are, there are still a lot of risk involved, right? Risk involved in the sense that um, there are different groups in those locations, some external, some internal. You may have taken care of the external threats, but there are also a lot of internal risks involved as well, right? So therefore, you have to ensure that you keep the different users and the different data, in different segments within the site, within the edge site. So you have to plan for segmentation technology of the edge location, right? And given the fact that now we have also new technologies being deployed there, including edge cloud, which is virtualized or which is containerized, right? So microservices technologies are increasingly being used at the edge also. And these kind of new technologies like virtualization and containers, right? They have a completely different kind of operations and cloud native practices, which are different from legacy applications, right? They are very chatty in nature also. That means there are a lot of connections and lot of transactions happening between the machines or between the servers, between the applications, right? So this is what we call as the east to west traffic. There's a lot of east to west traffic. The east to west traffic means there is a lot of there's a lot of I think interaction between different devices and different applications. Okay, so when this happens, we have to ensure that they are not communicating with somebody that they are not supposed to communicate with. Okay, they are not sharing data which they are not which is not supposed to be shared, right? So take for example a finance organization trying to use something about HR, or a sales organization trying to look at R&D. So these are things which are not supposed to happen. There is no reason why they should kind of try to access those things. So therefore, micro segmentation and zero trust together have to work hand in hand. So these things are kept separate. There is less mixing of traffic between those. So so you have to basically, in these days of AI, you have to basically take that you are anytime you are you are kind of hacked, or you are unsecured, right? So in that scenario, how do you respond quickly? So the way you respond quickly is by going in for this kind of segmentation, right? And continuously also not just doing zero trust one time, but continuously kind of doing analytics using AI, using machine learning, and using kind of visibility of the data that is coming out to do a kind of processing of the identity and the behavior of the user. So what we call it behavioral analytics. So these things help you to do a dynamic zero trust operation, right? So that it's not just one time; you are continuously doing, and therefore you prevent any risks which are due to very dynamic environments like AI coming in today.
Yes, and security clearly needs to evolve with the architecture. And your point on zero trust puts it in sharp focus.
Right.
So, all right, moving forward, I would like to ask that how should developers and infrastructure teams future-proof their skills and systems for this shift toward more distributed compute models? What do you think?
Yeah. So your question about developers and infrastructure is a good one, Kushi. So infrastructure teams and edge, developers are good when it comes to traditional edge technologies, which are either legacy application based or even cloud based as well. Okay, but when it comes to new technologies like AI, there are new skill sets that comes into play here. You not only have a need to understand the edge technologies, the edge infrastructure, the edge network. You also have to understand how AI, works. Okay, so when we say how AI works, it's not just the AI infrastructure, the server, storage, network, which are also very different from traditional infrastructure. Okay, very different. Okay, so they have to understand the differences of that. But not only that, they also have to understand how AI is trained and how AI is operated. That means it calls for understanding the data science layer, right? The AI model layer, which are very new to these edge professionals that we have had in organizations, right? So to that essence, there is absolutely a need to upskill themselves for edge. Okay, and importantly, not just edge, they also have to look at edge-centric AI. So AI that is, not just AI, but you have to look at edge AI-centric technologies and skill sets required for that, which is again very different. So a centralized edge or a cloud-based AI is very different from edge AI. The players are different, the equipment providers are different, even the models and the frameworks required to run edge AI is different. So therefore, it is a very specialized skill set that is required for edge, which is also a problem because it is fast developing area where there is a lack of skills currently. Even more, scarce skills compared to normal edge, which is deployed centrally.
Yeah, and that really sums up how proactive learning and system thinking are key to staying ahead in this space, I believe.
Yeah, and I think Kushi, this is a very critical area, which sometimes people don't realize that much. Okay, they feel okay, edge AI is like just another edge technology, which is not the case. Edge AI is very different from other edge technologies, and AI itself is very different from traditional, legacy applications, and even cloud applications also is different. Okay, that's one part. The second part is like I think many a times I feel the enterprises, focus too much on the tech, but they forget about the management and the people challenges involved. Okay, particularly in the case of edge. Edge is actually distributed, right? So in a distributed operation is always a challenge when it comes to people. You don't have a well-skilled engineers everywhere, and they are all basically sitting somewhere in a central location in an office which is centralized in a big city, right? But these edge sites are very remote locations. They may be across the world or across the nation. So how do you manage technologies in this kind of approach where the technology is distributed, the people are centralized? So this is a problem, classic problem, that edge is very uniquely, from other kind of technologies. And so therefore, I think one is to not just look at the technology side of edge, but looking at more at the management and how you manage the edge and how so that you can operate it properly.
Exactly. So moving towards the end, I would like to ask that what do you think is one bold prediction that you would make about the future of data center architecture over the next 5 years?
I think 5 years is too long a time period in these days. So I'll make a prediction for next year. Okay. So
yeah.
Khushi, I think the next 2 years, let's say, okay. So by 2027, we will have data centers that will consume more energy than some smaller cities and big towns of this country. They will consume more energy than towns and cities altogether. Okay. So to address this lack of power availability, and to also address edge requirements, data center operators will increasingly adopt a decentralized data center strategy. So rather than operating a single data center, they'll operate more data centers, but smaller in size, but more distributed. Okay, and those data centers will be very different from the data centers that we knew earlier. They will be very customized. They will be very, very consolidated, but they will use a lot of power, because they will consume power so that they can run AI. Okay, and for this purpose, they will not look at just the tier 1 locations. They look at locations which have got power surplus, where you have wind energy, where you don't have power challenges, right? Where there is energy available at a good price. That is also important.
Yes, and that's a very fascinating outlook, and definitely something that could actually redefine how we think about infrastructure planning.
Absolutely.
So, Naresh, I would also like to ask that what do you think about the Leaders Circle program here at TechGig, and what are your views on this initiative?
I think this is great. It's good to always exchange, ideas, opinions with the people that we serve, basically the enterprises. Your readers are our customers, so they would like to hear from us. Sometimes, because of commercial reasons, because of lack of time, it's difficult to communicate with all of them. But through your platform, we can reach out to a lot of users, including even those that do not have a commercial contract with Gartner. So we would like to benefit everybody in the country. So that we can do with platforms like this.
Yes, and thank you for that. It's encouraging to hear that it's helping bring industry leaders and developers together. So with that, we wrap up this truly insightful fireside chat on Edge versus Core, rethinking data center architecture for AI and real-time applications. A heartfelt thank you to you, Naresh, for sharing such valuable insights, practical frameworks, and forward-looking perspectives. Your thoughts have given us a much deeper understanding of how edge and core strategies are actually evolving in response to AI and real-time computing demands.
Thank you very much, Khushi. A pleasure, kind of talking to you.
Yes, and it was a pleasure having you with us. Thank you so much once again for being a part of this engaging and thought-provoking session. And it was an absolute pleasure hosting this fireside chat. Stay tuned for more such conversations from TechGig. Until next time, take care and keep innovating.
Bye-bye.
Thanks, Naresh. Thanks a lot.